All right, let's get to work here on this last supplemental assignment. Um, there's going to be two parts, really. One is on section 12.6 on linear regressions. And then the other one is I think it's like 12.4 ABC. That's on the confidence intervals. Okay, I know there's a couple worksheets on there, but I'll go through and try to make this a little bit easier. So let's look at some linear regression stuff. It says anthropologists can use skeletal remains to estimate the number of individuals, estimate the height of an individual when alive. Okay, the humerus bone of a male, prime indicator for height. Let H represent the height of a man in inches and L represent the length of the humerus. A linear model that relates a man's height to the length of this is created by this. So data was already taken, and they created this linear equation. H of L equals 1.14 L and 53.356. Okay, so the input is L. Okay, so what is L? L is the length of the humerus. Boom. Okay, so this is the input. What's the output? Well, the output is the height of the person. So they're estimating, if you find somebody's bone or humerus, you can estimate the height of that man. This is the output. Okay? So the slope, remember, is always the number in front of the variable. So in this case, it's the 1.14. And what does that mean? Okay, so interpret the slope of this model. So according to this, the height represents the height of the man in inches, and L is the length of the humerus. Okay, so for every inch that the humerus grows, okay, I believe this is going to be that H represent the height of a man in inches and L is represent length. Oh, so it's also going to be inches. So it's the change in the slope, remember, is the change in y over change in x. Okay, so it's the change in height divided by the change in the humerus. Okay, so for every 1 inch, I guess, change in humerus, the height is going to be 1.14. Okay, so the height is going to go up 1.14 inches for every 1 inch that the humerus grows. Okay. All right, so just think of the slope again as the change in y over change in x. Okay, so what does all this mean? A recent dig uncovered a man's remains whose humerus measured 12.4 inches. Predict his height during that life. Okay, so we're just going to use this formula. This is going to be H of 12.4. So it's going to be 1.14 times 12.4 plus 53.356. So, plugging all that in, what do we get? 1.14 times 12.4 plus 53.356. We're getting 67.492. And remember, this is in inches. Okay, 5 feet is 60 inches, so this person would be 5 feet 7.492 inches. Okay, so we're just predicting the height of this person when all we have left is the humerus bone. Okay, the tallest man to live was Robert Waldau. Okay, he stood at 8 feet 11 inches. Estimate the length of his humerus. So be careful here. We have to change this to to inches. So 8 feet is 8 times 12 is 96 plus 11. So this number is 107 inches tall. So this is the height. So I'm going to put that on this side of the equation. 1.14L plus 53.356. And then I'm simply going to solve this for L. So I'm going to take 107 minus the 53.356. And I'm getting 53.644 equals 1.14L. Divide by the 1.14. And I'm getting his humerus bone would have been 47.056 inches. So very tall. Okay? So, once we're going to use regression, we come up with this equation. We can use it to make predictions about other things. Okay? So here's one where we just give a table. There seems to be a linear relationship between a student's ATC score and his or her freshman GPA. Let G represent the student's freshman GPA, and S is the score of the ACT. Below is a table with a freshman year's GPA and an ACT score. Find the linear regression that fits that model. So this is really what we're going to have to do. So the first thing I want you to do is we're going to go into Stat Edit. I have a couple things in here, so I have to clear these things out. So I'm going to clear list 1 and list 2. And then in list 1, I'm going to put in the GPA. Okay? I'll do it over here. I don't know where you can see it. So my GPA is 2.4, 3.1, 2.6, 3.5, 4.0, 2.3, 2.9. And then in L2, I'm going to put the ACT score, 22, 27, 24, 30, 31, 22, 27. Okay, make sure they match. You should have the same number in L1 that you do in L2. Okay, then to find your regression equation, we're going to go Stat. We're going to move over to the right to Calculate, and choice 4 is the linear regression. Now in my calculator, it gives me this drop-down menu where it tells me list 1 is L1, what my Y list is L2, and then I can go ahead and just calculate my linear regression. If you have an older version of this calculator, you may have to type in list 1 and list 2, which is underneath your, or on top of your number 1 and 2. So I'm getting, and I'm just going to round to 2 decimal places, I'm going to get Y equals 5.73x plus 9.12. Okay, notice it gives me the equation Y equals AX plus B, and then it gives me that. Okay, all right, now if you also notice, I did not get my R value here. You're going to need that in the for some of the problems, I think, in my math lab. Okay, so if I need to get, if you don't have the R value here, we need to turn that on. So I'm going to hit second catalog, and then I'm going to scroll all the way down to the D's, and I'm looking for a command called diagnostic on. So I'm scrolling down to the D's, and I'm looking for diagnostic on. And once you do this, you won't have to do it every time. Just turn it on. So here I found it down here in the D's, diagnostic on. I'm just going to hit enter again, and all it says is that you've turned it on. Now when you can do your linear regression, not only are you going to get the linear regression equation, but you get the value for R, which you're going to need. So don't compute R by hand, okay? When it asks for your correlation coefficient, it's 0.972 in this case. So I'm just going to write it on here, even though they didn't ask me for it. Okay? And again, that tells me how closely related this is to a linear equation. So 0.97 is pretty high. So there appears to be a pretty good correlation between ACT score and freshman GPA. Okay? So going back to this model, what's my input? Well, X is your freshman year GPA. What is your output? What is Y? That is your ACT score. Okay, so we're always kind of keeping track of what our input is and what our output is. What's the slope? Your slope is the 5.73. And what does that mean? Okay, well, what that means is for every point that your GPA goes up, your ACT is going to go up by 5.73 points. Okay, for every 1 point. So again, this is only out of a 4.0 scale, but basically what this means is for every 1 point your GPA goes up, your ACT score goes up. I'm running out of room. 5.73. Okay? So the difference from a 3.0 to a 4.0 is about 5.73 points on your ACT score. Okay? All right. So let's see where we go next. It says a recent application listed the student's ATC score as 22. What would we predict her freshman GPA to be? Okay, so here I have the ACT score of 22. So that is the output Okay, so I'm going to set that on the left side. So 22 minus the 9.12 is 12.88. So divide that by 5.73, and I'm getting 2.25. So I would predict that student's GPA to be around a 2.25. Okay. Another way we use this, Allie finished her first year with a GPA of 3.4. What's her estimated ACT score? Okay, so here I'm just going to say ACT equals 5.73 times 3.4 plus 9.12. So 5.73 times 3.4 plus 9.12, I'm getting 28.6. So roughly around a 28 or a 29 would be our predicted ACT score. Okay, so that's a little bit on the linear regression stuff. Sometimes you have to calculate the equation. Sometimes it'll be given to you and you just need to interpret what's going on. All right. Then let's look at this last section on section 12.4, which deals with the confidence intervals. Okay. All right. So there's going to be two types of things that we're doing here. One is going to be qualitative data and the other one is going to be quantitative data. All right. Let's say we take a random sample of 400 people and we found that 260 people have the vaccine for COVID-19. Okay. So we may want to know, this is just a sample of 400. We want to maybe know, okay, of the population, how many people on average have had this vaccine. So we're going to create a 95% confidence interval for the actual number of people that have been vaccinated. Okay. And we're going to assume that all these conditions are met and we're able to create this. Okay. So we're not going to get into any of that stuff that was on the worksheets. Okay. So is this qualitative or quantitative? Okay. Well, the question would have been asked here, have you been vaccinated? It's a simple yes or no question. So we're not taking in a number, we're taking in an answer, yes or no. This makes this qualitative data. Okay. So which formulas then are we going to know? Once we know that this is qualitative, we're going to use a proportion. And our proportion is just going to be the number of successes divided by the total number of people. So in other words, this is going to be 260 out of 400. Our percentage from our data that we collected is 0.65, which is about 65%. Okay. So what we're going to use for standard deviation, okay, the standard deviation that we're going to use is going to be from this formula. And I only do this when it's qualitative. So you should need kind of take note of this. Once we determine that this is qualitative, these are the numbers I'm going to use. Okay, so my standard deviation becomes 0.65 times 1 minus 0.65 over 400. So 0.65 times 1 minus 0.65 divided by 400. And then I'm going to take the square root of that. So I am getting, I'm going to say 0.02. And that's the number I'm going to use. Okay. All right. So P is 0.65. My standard deviation is 0.02. And now I need to compute, whoops, I did that down here. Okay, which is okay. All right, so compute P and find standard deviation. I already did that. Oh, it looks like I didn't really leave enough room in here for the interval, so I'll do that up here. All right, so remember what we're trying to do here in general. If we assume this is normally distributed, the mean has to be somewhere in here, or the true population percentage has to be somewhere in here. But we just took a sample of 400 people. So it could be 65, it could be 70, it could be 60. We don't know. What we're trying to do is find an interval where that true average is going to fall. Someplace between here and here. Okay? So what we do, we're going to use, because it's 95%, the z-score associated with 95 is always going to be this 1.96. And that's what we're going to use in this class. Okay? So this goes back to our kind of our z-score stuff. Okay? But this is going to give me my 95% interval for this data. So it's basically just 0.65 plus or minus 1.96 times 0.02. So it's 0.65 plus or minus 0.0. I'm going to round this to 2 decimal places and get 0.04. So 0.65 minus 0.04 is 0.61. 0.65 plus 0.04 is 0.69. So based on my data, okay, from our 400 people, I think the true percentage is somewhere between 61 and 69%. I know this is just from the sample, this 65. So we compute those, and then we use this formula to compute my interval. So this is really what you need to have. Okay? So we are going to say that we are 95% confident that the percentage of all people who have been vaccinated is between 61 and 69%. So that's what we're doing when we're calculating a 95% confidence interval. Okay? We're taking some data and then we're trying to make a prediction about the entire population. Okay? Obviously, it's not always going to be exactly 65. I could have interviewed a different 400 people, and maybe I would have gotten 270 people that were vaccinated. So my prediction here is that the true average lies somewhere between 61 and 69. Okay? It's a little bit different with quantitative data, and that's what this next one looks at. The number of times my wife complained that I left the lights on per day was recorded for 30 days. The mean number of times was 6.7, and I had a standard deviation of 1.3. Okay. For these, we're going to assume the population standard deviation was 1.2 because that's what we use here. Okay. So this is a little different because it's quantitative data. The question would have been, how many times that day did she complain about me leaving the lights on? Okay. So it's not a yes or no. It's how many times. So I get a quantitative data. So that's why I'm going to use the mean here. So what formulas am I using? Okay, well, I'm going to use X bar. okay, for the mean, okay? And then for my standard deviation, we are going to use the population deviation, which was given to us, over the square root of n, okay? And then my confidence interval is x bar plus or minus 1.96. Again, it's always the 1.96 because it's a 95% confidence interval. Okay. If we were in stats class, sometimes we do a 90%, sometimes we do a 99%, and all that changes is your z-score here. Okay. So these are really the formulas I need. This should say compute the mean, which was given to me. The mean was 6.7. My standard deviation is going to be the population, 1.2 over the square root of n, which was 30 days. So I'm getting 0.22 if I round it 2 decimal places. Okay, so that's really what I need to do the interval. Then it's going to be 6.7 plus or minus 1.96 times 0.22. So 1.96 times 0.22 is 0.43. Okay, so my 95% confidence interval is 6.7 minus 0.43, which is 6.27. That's the low end. 6.7 plus 0.43 is 7.13. Okay, so my statement is we are 95% confident that the average number of times my wife complains about the lights every day is somewhere between 6.27 and 7.13 times. Okay, so again, we're making a prediction about every day, okay, using the data from this 30 days. Okay, so again, for these confidence intervals, you need to figure out, is it qualitative or quantitative? If it's quantitative, we need this information. If it's qualitative, we need this information. So make sure you're taking notes on that. Qualitative, we use a percentage. Quantitative, we use the mean. Okay, so let's put all this together. We take a random sample of 300 people and find that 230 people have seen the movie Avengers Endgame. Create a 95% confidence interval for the true percentage of people that have seen the movie and make it a statement about that. Okay, so is this qualitative or quantitative? To figure that out, just kind of ask yourself, how did they create this data? And this would have been, did you see the movie Avengers Endgame? So the answer is yes or no. This is qualitative. Okay? Because it's just a yes or no type thing. We're not asking how many times you saw it. We're just asking, did you see this? So what formulas? Well, because that's a percentage, it's qualitative. We're going to use p hat, and we're going to use this for the standard deviation. And then for our interval, we're going to use p hat plus or minus 1.96 times this. And I did all that because this is qualitative data. Okay? So how do I do this? P is just simply 230 out of 300. And we're rounding these to 2 decimal places. So I'm going to get 0.77. Okay? Then my standard deviation that I'm going to use is 0.77 times 1 minus 0.77 over 300. So 0.77, 1 minus 0.77 divided by 300. And then I'm taking the square root of that. And I'm getting 0.02. Okay, so my confidence interval is going to be 0.77 plus or minus 1.96 times 0.02. So 0.77 minus 1.96 times 0.02 is 0.73 on the low end. 0.77 plus 1.96 times 0.02 is 0.81. Okay? So my statement would be we are 95% confident, okay, that the true percentage of all people who have seen Avengers Endgame is somewhere between 73 and 81%. Okay? So hopefully that clears up some of that confidence interval stuff. There's only a couple questions in the homework, and I think there's only 1 or 2 questions on your test. So hopefully that helps. Good luck, and we are almost done. 1 more week.